For one of the questions sent by Rishabh, uh, asking that can we do a selective fields in the merge transformation? The answer is no. Hello? Yeah, I'm hearing echo. Okay, I'm muting you all, and if you have any questions, please unmute or ping me on chat. All right, perfect. So yeah, the question, like when we are doing a merge on different tables, can we do a selective field merge using the merge transformation? That was the question by Rishabh. And the answer is no, you cannot do a selective field merge because in merge transformation, we do not get to choose anything. Everything is done by the system itself. So if you look at this one, so within the merge, you are not allowed to do any selections or anything, okay? So automatically, if all the source structures are same, then it will be merged into a single set. If not, if you want to do a merge on only the first 4 fields or first 5 fields of each table, what you can probably do is add a query transformation before the merge transformation here. Okay, so you remove these connections. Okay, add a query transformation before these things. Before the merge transformation, add 3 queries. Okay, connect the tables with the query transformations. And now you can do a selective field selection like till shipwire. Then go back, connect query 1 to the table 2. Select till shipwire, drag and drop it. And the third one, select till shipwire, drag and drop it. Now connect it with the merge transformation. Now you are filtering not all the fields, like you are not selecting all the fields, you are just filtering on the number of fields that are required by you for this merge. And now if you look at the merge transformation, it selects only those fields from each table which you have selected in the schema out of the query transformation. So this is the selective merge that you can do with the fields. I'm saving it, validating it. There are no errors found, and if you execute only, you can see the first 4 or the 5 columns that you have selected for the merge. Yeah, Rishabh, is your question answered? All right, most welcome. So yeah, and I think, yeah, Gopal, I think I have created the repository, and even for Jairam, I created the repositories for you in your machine, so you can start working on that. So please start working on the tool, because when we have learned more, so I don't want you to miss out anything, so just start practicing on these things. So till now we have seen the 3 transformations of platform transformations. One is case transformation, second one is merge, and the third one is query transformation. So today we will look at the remaining 3 transformations, or if possible the 4 transformations. Okay, so next one is row generation transformation. So what is row generation? Row generation, it generates a column filled with int values starting at 0 and incremented by 1 to the end of the values you specify. For example, if you specify 1 to 100, so it gives you the value 1 and it increments only after 100. So it is like a unique ID that you provide for a table. And I will show you the difference between row gen and generate row number function. So I call this job underscore row gen. And I'll tell you one more trick. The real usage of this one within a project is utilize this row gen transformation in the place of a source table when the source table is missing. Okay, I repeat, utilize this in the form of a source table when the source table is missing. This is a source transformation. You don't have any left side connected to it. You have only a right side connected to it. And this is a source transformation. So just in case you are trying to reuse some data flow. Okay, for example, you want to create a table structure. So what you do is create a row generation for this, and in the schema out you create new output columns and call this as old underscore Matner for material number, which is of varchar 16 or 16, and the second one is new output column new underscore Matner, and it is of varchar 16. Okay, so we want to create a cross-reference table like this, where the data coming from the source has to match with this one, and it should get the new value as an output. So we can do that using a query transformation, which we'll see a little later using the built-in functions. But this is the scenario, and we don't have this table structure. So now what my intention is to create this structure anyhow, because in future the client is going to provide me the data for this, and I'm populating these with the null values because all the columns in the schema out has to be populated. So I'm trying to populate these with the null values, and I use a table called lookup underscore Matner. Okay, and I'm saving it in the target data store. Connect it. Now you see this table structure is having two columns, old material number and the new material number, but there is no source table, but still this job gets executed. So you might think that we are not populating anything from the row generation. Now you see the job is successfully completed. You might think that your job is not generated, I mean we are not populating anything from the row generation. But if you look at this one, okay, if the same job I remove this row generation and try to execute this job, it throws an error saying that there is no source table, right? So if you see, either selected from no objects at all. Okay, so the query is selected from no objects. Please re-edit the query. It gives an error that there is no source table. So you can use this row generation transformation as a source table when you don't have a source table, but probably the output columns you have to map by yourself. You're not mapping it with the table. Okay, that is use number one. That is the main use of this row generation transformation. It is used in place of a source table when you don't have the table, but still you want to create the structure. You will use this one. Okay, so the second one is, okay, I drag and drop it to the output table. Now open the row generation, and you see the number is starting with 0, make it to 1, and the row count is 1, incremental value is 1, and the join rank is, okay, let me make it as 10, and join rank is 0, and we'll ask the system to utilize the cache memory. You want to check this box, you can check this. So if I execute this job now, I selected the value row ID, okay, from schema in to schema out. I move this as it is, and here I give the values from 1 to 10, and if you look at these values, so it is giving the values 1 to 10 because there is no source table. So we have, yeah, join rank. Join rank is always 0 because this will allow which is the first one. I mean the rank, if you get a least rank, then you will be called the topper of the class because it starts from 1. Okay, 1 is the least number, but it is the top of the class. And if it is 2, then when you want to choose between 1 and 2, you will always choose 1. The topper you will choose. So similarly here, every source table or source transformation that you are using comes with a join rank, and this join rank allows you to choose which has to be selected first and which has to be selected second. Okay, even if you leave it 0, there is no problem for that. Okay, all right, so this is how it works, row generation transformation. And one more built-in function is there, or let us join this row generation with the table so that you can understand the clear difference of this one. So I'm joining this with the orders table. When you are using a row generation, there is no need for you to specify a join between the tables. Okay, so I'm taking some of the columns to the output, and let me keep this as row count as 2. Now if I execute this job, it's executed successfully, and now let us look at the records. You have double the volume of records. Generally, the source table has 830 records that are coming from the source table. So we go to the profile tab and click on records. So orders is the source table. So we have 830 records, but here we have double the records, 1660, because 1660, because here you are giving the row count as 2. So make it as 1 and try to re-execute this job and see the difference. It gives a unique number for the entire data, right? So now you see, second, this is a source table. So now you see, count is 830 records, and if you look at this one, the data. So order ID, you can see only number 1 here. Okay, so the definition of a row generation, you can take it this way, is it generates a unique row number for the entire data set. And if you use the row count value as more than 1 or 2, then based on that it gives you the row counts. Okay, so that is a row generation. And if you want to see the difference between the row generation and generate row number, what you can do is you can remove that one. You can go to the query transformation, and DI row number is already there, so you can just delete this one and use the function generate underscore row underscore number. Okay, so this kind of gives us an indexing on the data. Generate row number kind of gives us an indexing on the data. That is the difference. Row number generates a unique number for the entire data set, and generate row number creates an indexing on the data. So now you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 830 you'll have this one. So I'm using a built-in function. I told you when we are looking at the query transformation, I told you we can utilize the built-in functions to populate the column. So I'm using this generate row number of function. So it's very simple. All you need to do is like go there and type GEN, and you can get the message here, generate row number of, close the parentheses and utilize this. So this is how we will be using these built-in functions on this one, and this is the main difference between the row generation and generate row number transformation and functions. So this can be your interview question, or this can be your certification question, because there is a very slight difference even in the spelling. Generate row number or row generation transformation, there's a very small difference between them, and you have to be very clear, like generate row generation is a transformation and generate row number is a function. Row generation creates a unique number for the entire data set, and generate row number creates the indexing on the data set. So this is the difference. Next one is the SQL transformation. So SQL transformation is utilized to do a push down operation. So what is a push down operation? What is the benefit of using an SQL transformation? So SQL transformation, so what are the code that you provide within the SQL transformation? It executes the code back in the database, and it retrieves only the output to the data services. So this is how it works. So let us assume this is our PODS screen, and this is the backend database. So right, so this is your source and this is your target table. So whenever you execute any transformation, it gets executed within the PODS cache memory, and the output is sent to the target database. So this is how it generally works. But when you use the SQL transformation, okay, when you use the SQL transformation, one second. what happens is it connects to the data services using when it connects to the source database using your data services, and whatever the calculations that has to be done will be sent to the backend database or to the source database or wherever you are defining the SQL transformation. Everything is sent to the backend database. Every calculations, every logic that you provide within the code happens within the database. It is pushed down to the database level. Every execution happens on the memory of the database, and only the results are sent back to the data services designer, and it is sent back to the target system. So if you look at a normal execution, the data is extracted from the source table, all the calculations happen within the BODS cache memory, and again the data is sent back to the target schema. But when you do a push down operation, it means it is pushed down to the database level, and all the calculations, executions happen within the database level, and only the data is retrieved. There is a very good example for me, a testimony about this one. When I was working on the first project, I have to join so many tables. There are some A tables and tables called A tables. The table name that starts with A, and these tables have some information related to the materials and vendors. So I have to extract the data from all these A tables. There are like 53 to 60 tables from the SAP source. So when I am extracting, I was able to extract, but when I'm trying to join all these tables, I was not able to do, because practically I was doing it on the data flow level, and I'm trying to optimize the job performance by doing one join in different data flows. But at the end of the job execution, so the job is getting executed, but it is running unendingly. It is not getting stopped. Now this is running for quite a long time, because there is no enough cache memory in my system or in the job server, so that it can handle such huge volume of data or so many tables. Because if you take 10 tables, or at least if you take 2 tables, the join, and if you are trying to join between these 2 tables, the iterations happen in a way that number of records in table 1 into the number of records into table 2. So that many iterations. For example, your table 1 has 100 records and your table 2 has 50 records. 100 into 50 iterations happen within the cache memory. So imagine I'm trying to join 153 tables. That is a pretty huge task. So designing way, you can do it within the BODS system, but practical execution will not happen. So when we utilize the SQL transformation, so it got executed in less than 3 minutes. So the job which is running unendingly can be reduced to 3 minutes job by using the SQL transformation. As it does a push down on the database level, everything is calculated within the database, and only results are retrieved. And this is also your source transformation. It does not have a left hand side connector. This is your source transformation. So now open the SQL transformation. You have to select. This is how it looks. You have a schema out on the top, and you have a SQL tab, and here you have to select the data store. It gives you the list of data stores that are coming from your system. So you select Northwind, that is your source database, and automatically it selects the database type and all. Join rank, as you know, it is 0. And if you want to prefer this with something else, you can select, give the join rank 1. And array fetch size, it is by default 1000 records. So it is like when a request is sent to the database, how many records are fetched in that array. So that is the one that you have to specify here. 64,000 is the maximum array fetch size that you can give on the system. So by default it will be 1000. Just let it be 1000. So now select, write a simple select statement. Select star from orders and click on update. So it is not giving the table name properly. So select ORTES. Okay, what it says is okay. Okay, so I think, yeah, thanks Rishabh, thanks Gopal. So let's start from orders, click on update. Exactly, thank you, thanks a lot. Okay, now what it does, once you write a simple select statement and click on update schema, it gives you the structure of this one. Now you can write more complex queries here where ship is not equal to 1 and you can give more complex queries here. So now what it will do, it will do whatever the calculations, or if you are trying to join two tables uh, to join two tables and write a query here. So what are the complex query that you write here? It gets pushed down to the database and every calculation happens within the database and only the results are retrieved to the BODS system. So now it saves the BODS cache memory. Nothing is getting executed within the BODS cache memory and it is pretty fast compared to the normal transformations. Generally, you do this when you are using huge volumes of data. So now if you see this one, we don't have shipwire is equal to 1. So you have 0 records because I applied that in the filter in the SQL transformation. So this is a simple statement that I'm saying, but when you have huge number of tables, when you are trying to join many tables together, then probably you have to use the SQL transformation so that everything gets pushed down to the database level and only the results are retrieved. Okay. So this is about the SQL transformation. You can write filters, you can write commands, you can write joining conditions between many tables, you can do everything. Whatever you can do on a database level coding, you can do within the SQL transformation. So there is no limitation to that. Whatever you can do on the database level, so even you can create a table structure using the SQL transformation. Okay. So you can do all those things onto the SQL transformation. And next transformation that we are going to look at is the validation transformation. So this is one of the most important transformation when you are working on a project because it validates the data. It validates the data based on the conditions that you specify. So generally, what will be the conditions that we specify to validate the data? So for example, if you have a data that is coming in from the source table, for example, the source is a material table and there is a strict limitation on the target table saying that the material number should not exceed more than 16 character length. But from your source table, you have some data coming with the preceding spaces. So as I told you earlier, the data, the value 1000 is never equal to double space 1000. So because, let me open a notepad and show it to you. So the first one is 1000 and the second one is double space 1000 or single space 1000. These both values were never equal because when it does a comparison, it compares between the image to image of the data, and this one the length will be 6 and this one the length is 4 because you have two preceding spaces here. So this is how the data gets compared and this is how it works. So your data will never match if your data source is having 1000 and your target is having your lookup is having double space 1000. So in order to eliminate that, what we do is we use some built-in functions to eliminate the preceding spaces, which we'll be looking at a little later. And also parallelly, if you load this double space 1000 into the target system, the value 10 will be loaded because the target system will be specified with the length 4. So 1, 2, 3 and 4. So these two records will not be added. These two digits will not be added. Only 10 will be added because the length of this one is 1, 2, 3 and 4 because you specified that this material number is 1000. and the length of this one is varchar 4. So only 4 characters will be read. So space 1 and 0 will be read into the target system. So to avoid these kind of things, avoid sending bad data into the target system, we do validations on the data. We generally do 3 types of validations in a migration approach. The first validation is format validation, where we check the length of the data is not equal, is correct. So if the target table says that the length of this one is 4 and this is having a leading spaces, the length of this one is 6, then automatically this record, even though it is 1000, it goes into the invalid table. Okay, so that is the format validation. We check the format of the data to ensure that right data goes and sits into the target database table. And the second type of validation that we do is a mandatory validation. So if you define a table and you create a column as a primary key on the table, so if you look at the data within that, the primary key should not have any null value. So that is a mandatory column. So if you look at the employee number in the employee table, employee number is a mandatory column. And in that column, if you are having a null value, the data doesn't make any sense. So for whatever the fields that are coming from your source table with a primary key on top of this, you have to do a mandatory validations on them to ensure that there is no null record passing into this column. So if there are any null values passed into that column by force, or they are passed and later the column was made into a primary key, then in that case this validation will allow us to capture those invalid records which are part of your primary column, which are nulls, will be sent back to the invalid table. And the third one is the lookup validation. So there are 3 types of validations that we do at most. One is the format validation, where we check the length of the particular data. The second one is mandatory. We will see it is not null. And the third one is lookup. So in lookup, what we do is, for example, let us take these 2 tables, orders and order details. And the order ID that is present in the orders table, to be a valid order ID, the same order ID should be present in the details table. Then it is a valid ID, because, for example, let us take the employee number. Some employee test 100 is created in the database table, but this is not present in the unique list of employee tables, then definitely it is not a valid employee number. So it should have a cross-reference table, it should have a lookup table, or it should have a list of values in which the values that are coming from the source are present. Then it is a valid record. If not, it is an invalid record. So this is how your validation transformation works. So you have your validation here, and your source data, and the output of validation is 2 tables, valid and invalid. So the source data flows into the validation, and if it is valid, it goes to, if the business condition like mandatory, format, or lookup, if any of this one is honored, it goes to the valid table, and if any one of that validation is not honored, dishonored, it goes to the invalid table. Okay, this is how your validation works. Now let us see on the system how it works. df_validation. Okay, so now go to the orders table, make it as source, open the orders table, order ID is a primary key, and shipping name. So we'll do a format validation on this, mandatory validation on this, and lookup validation on this. Okay, we'll perform 3 types of validations. So remember, this validation, what we are trying to do now, will be as same as your real-time jobs. So this is the standard across the versions of the best practices I have seen. This is the standard way of doing this one. Alright, so now go to the transformations, select the validation first, and call it as validation underscore MANDT, mandatory validation. The second one is validation underscore format, And the third one is validation underscore lookup. Okay, I add a query transformation here. Connect this one to the query transformation. Open the query transformation, select all the fields, drag and drop them to the schema out, and now connect this query transformation to the mandatory format and lookup. Okay, now go to the mandatory validation, and the validation that we are trying to do is on a primary key, and enable validation. This is the checkbox that you have to enable and disable the validation. This is the checkbox, and the condition is not null. Okay, so I'm selecting order ID, I'm clicking on enable validation, and the condition is not null. There are so many conditions: less than 1000, less than or equal to 1000. You can give any value in place of 1000. Not equal to 1000, equal to 1000, greater than or equal to, is null, like, or is not null. When you are doing a mandatory validation, remember that the primary key is not null. So I'm selecting is not null here, and if you are selecting is less than, you can give a value here. Okay, you can give any value here. So is not null is the one. And if you look at this structure transformation, you have a schema in, you have a schema out, and you have the validation rules tab where you can enable the validation. And when the data is coming with null values, you can opt do not validate when null. So when the data is null, do not validate this, just let it pass to the pass table, valid table. And next one is the condition. The first one is not null. And second one is in the list of values. You can define a list of values. For example, this particular order ID is either it should be A, B, C, or D. Then you have to give the values here. Then between 1000 to 2000, you can specify the range. Match pattern, if it has special characters, you have to give the pattern here. Custom validation function, you can write a own function and call that function to validate this particular order ID value. Exists in the table, which we'll look at later. And custom condition, if you want to write some custom condition, you can write your own custom conditions here. But as of now, I'm taking is not null because this is a mandatory validation. So if you, the moment I select, you look at the custom condition, it gives you a statement saying that is not null. So that is the mandatory mandatory validation. Again, you see something else too here. So you have the properties tab, the name and description of this particular validation. You can give the name and description of this particular validation. I can give like MANDT, and I can give MANDT. And action on failure. When this particular rule that you are specifying here is failed, then send it to fail. That is the default one. Or even though if it is failed, you want to send it to pass, but just you want to try doing some validation on the data, you can select send it to pass, or you can send it to both. Okay, and when you select send it to path or send it to both, the bottom part will be reactivated. Pass, for pass, substitute with. So when you are sending a bad record to the pass, means here the case is not null. So just in case your data is null, then substitute that with a default value ABCD. Okay, you can do this. This is a normal validation procedure. So because you don't want to push a null value into the target table, what you can do is you can replace that null value with a default value as ABCD when you are sending the invalid data into the pass table. Or if you just send it to fail, this will be grayed out. There is no need to use this one. And next one is validation transformation options. Collect the data validation statistics and collect sample data. The backend system will collect the statistics of the sample data. So now we have seen how to do a mandatory validation. Now let us see the format validation. So ship name, I told you we'll be doing this on a ship name field. Now select the ship name field, click on enable validation, go to the custom condition, and type here LENGTH of the ship name is less than or equal to 20. The actual data size that is given is 40, but our business would say that the shipping name should not be more than 20. So I am giving here less than or equal to 20 here. Okay, validate and see if it is syntactically correct. So this is the format validation. You check the length of a particular data should not exceed this value, so that when you push into the target table, the values of this remain same. Remember the example that I told about table 1000 and double space 1000. So it checks those activities here. And the third one is lookup validation. So order ID, we'll do a lookup validation on order ID. Select the field, select the enable validation checkbox, select the radio button exists in the table, do a drop down. You have to click on this, you have to do a drop down here, select the database or data store, and select the table, order details and order ID. So we had a discussion saying that if the order ID of the orders table is equal to the order ID of the order details table, then it is a valid order ID. If not, it is an invalid order ID. So now this is the lookup transformation. The order ID of the source is existing in the table, the order ID of the lookup table. So these are the three types of validations that we'll be doing as a part of the validation transformation. This is a global standard, so any project you work on, this will be the standard validations. And after that, you have to do a merge. And I call this as merge valid, and the next one is merge invalid. Why I need to do this? Because the validation transformation always has two outputs. One is pass and the second one is fail. Okay, so if record 1 is passed, it is sent to the merge valid, and if record 2 is failed, it's sent to the merge invalid. Similarly, for the format, we send it to pass and we send it to fail. And similarly, for the third one, lookup, we send it to pass and we send it to fail. So whatever the records get kicked off here, it goes to the failed merge invalid, and whatever the records that get posted here or passed here, passes the business condition, it goes into merge valid. Now I have a question. So if record 1 is passed in this, the same record is passed in this, means the record 1 is going to twice to the merge valid. So what it will do? The duplicates. To avoid duplicates, what we need to do is add a query transformation, go to the from select tab and select distinct records, so that it will eliminate those sort of duplicates which are coming from this remaining tables, and only the unique records are sent to this valid table. Okay, only the unique records are sent to the valid table. Okay, well, that is good, but what about the invalid table? I don't want to use any query transformation or any distinct transformation to get the invalid data. I don't want that. I want all the bad data to go and sit into the invalid table. Why is it so? Okay, there's a question from Rishabh asking, please explain the query step again. Rishabh, if a record file from the source table, the fifth record, is passed here, it passed here, and it passed here, thrice it goes to the merge valid, right? It goes thrice into the merge valid, and 3 records, the same fifth record, 3 times it is sent to the merge valid, and from there it will be sent to the target table thrice. Means we are doing a duplication of the data when we are doing a validation. So we do not want to duplicate the data. For that reason, what you go do is go to the select tab of the query transformation and select distinct rows. So it will eliminate those duplicates, and only 1 record is sent to the valid table. So that is the reason why we are using the query here. And for the invalid, I'm not using a query transformation. I'm not using a select distinct from a query transformation. Can anyone guess why? because I want to know what are the possible reasons a particular record is failed. So if a record is failed in this one and this one, so the record goes into the invalid table twice, so that I can understand this is a primary key which has a null value, and this particular column from the source table does not honor the format as well. So if I rectify only the source column and for the primary key column and send it back to the job, again the same record gets failed because it is not honoring the format validation. So I want to know what are the possible reasons why a record can get failed and pushed into the invalid table with the help of all these three validations. So that is the reason why I'm not selecting any distinct query here. So if a record is failed here, it will be sent. The same record is failed here, it will be sent here, and if the same record is failed, it will be sent. So invalid table, I'll be seeing three records saying that this particular record 1 is failed because it is not a mandatory honoring. The second one is it is failed because the format of shipping name is greater than 20 character length. And the third one, the lookup, it is not valid already because it is not present in the invalid table. So can you add the reason for the failure in the validation? Yeah, you can add that one, because by default, if you look at this one, the error column and error actions come with the invalid table. The output, so if you look at this valid, you don't have this one. The data as it is coming from the source will go, and this invalid has these two extra columns. Error action is like if it is a pass or a failure, so it will be an F, and the error column name, this describes what is the reason for the failure. Good question, Rishabh. I'm executing this job. The two extra columns, these are not tables, these are the two extra columns, Rishabh. Yeah, these two extra columns come from the transformation itself. So if you look at the transformation, right, so you have two parts here. One is pass and the second one is fail. In the fail you have these two extra columns, but if you look at the pass you don't have them. Because the reason why we are doing a validation of the data is to ensure that bad data is not going. And if there is bad data, if you don't give a reason why it is bad, then the data owners or the business might not accept your point of view. So if they want to know why this particular data is bad, so that is the reason why it gives you the reason around here. So if you look at this one, so some 201 records are invalid, and let us go and look at the reason for the invalid data. So now the validation format, so this is failure because of this selective transformation failed rule, and the reason is via the ship name, because the ship name here is more than 20 character length, and all these records, 201 records, got failed just because of the only reason. And if there are any failures due to the mandatory, it gives you validation underscore MANDT failed rules on this particular order ID. And if there is any failure because of the lookup transformation, it gives you validation underscore LKP failed rule and the order ID column name on which we are doing that particular validation. Okay, this is how the data owners will understand, okay, these many records failed on this particular column because of the business logic that we have provided, and they will look at the data and they will do all required changes on the data. So this is how you will be validating the data: mandatory, format, and lookup. These are, remember this is the blind rule sort of thing. So anywhere, any migration project, you have to work on this. This is a blind rule. So it is mandatory, format, lookup, and validation. Then you have to merge all the valid and merge all the invalid. And invalid will get two extra columns: error action and error failure. So this failure reason will be captured in the error description columns, and the valid data goes into the valid table. Okay, so that is about the validation transformation. And one more thing for your point, we'll look at that a little later. So here we'll be adding one more column called row ID, the extra output column, and populate that with the row number generation function, generate row number function. Because so in that order it creates an index on the entire orders. So for example, if you have 830 records, it creates an index from 1 to 830 on this. And why we need to add a new extra column here is a record which is passed in this transformation can fail in this transformation, right? So what it does, when it is passed, it is sent to the valid table, and when it is failed here, the same record is sent to the invalid table. What happens if two validations are correct and one failed? Yeah, Jay, we are talking about the same thing. For example, a particular row, it passes these two validations and only one record is sent because of this thing here, and it is failed in the third validation. It is sent to the invalid record. And when you say invalid record, this invalid record should not exist in the valid table. So that is the reason why we are doing this. So for that reason, what we will do is we will write a deletion script after this data flow saying that select that particular user ID. So we'll use a script here and call this as deletion underscore script. So I'll connect this and write a statement saying that SQL off, and you'll give the schema name or the data store name. That is, I'm just giving it as source now. So we'll write a statement saying that select star, no, it is a delete statement. Delete star from valid table where select distinct, one second, where row ID that we are generating in select distinct row ID from invalid table. So this is how it works. So first it will execute the subquery and it selects the distinct invalid, because the row ID can be repeated because it can be failed due to first validation, second validation, or third validation. The same row ID will be present thrice in this table. So first what we'll do is, like, we will select the distinct row IDs from the invalid table, and if we will see if the row ID that is present in the valid table is present in the invalid table, then we will delete all those records. So that is the reason why I'm using delete star. So this is how we handle that, Jay. A good question. Okay, Jay, is the question clarified? Okay, go ahead with your question. Can we inverse the operation like delete first and then insert the rows into the final target? Probably no, because this is the best practice that SAP has provided. And yes, if you want to do that, what you can do is you can add a query transformation between these two tables and say that if a particular serial number is present in the invalid table, then do not push it into the valid table. Or you can do that, but that is not a good thing. This is a very simple thing. You just push it into the valid and invalid table, and then come out and write a query transformation script to delete those records which are present in the valid table, which are a part of the invalid table. You just write a script to delete that. All right, Jay. So that's it. These are the transformations. Please practice them in a very nice way. And one more thing that I want to add here is this validation transformation. There is a slight GUI change in the version 4.0. So just keep that in mind with guys who are working on 4.0 system. It is almost the same, but there is a slight graphical user interface change. So just go through that. And you have any questions, send me your questions through your emails, and I'll respond to that, because I have another system where the 4.0 is installed, and I can take a screenshot from that, and I'll tell you how this can be done and all those things. Okay, so any questions for today's class regarding the row generation, SQL and validation transformations? If you have any questions, please send me an email at po.dataservices@gmail.com, and I'll respond to your questions as I do always at the earliest. And we'll catch up tomorrow at the same time. And tomorrow we'll be looking at the map operation, which is the last transformation of the platform transformations. Along with that, we'll be looking at some of the integrated transformations as well in tomorrow's class. So once we complete these transformations, then we can go ahead and look at some more interesting topics like configurations, data insight. We can look at the real-time jobs. We can look at the administrative parts and all those things. So let us complete these things one by one. But trust me, if you know in and out about the platform transformations, then you'll be as ready as a 2 years experience consultant to do a migration project. So prepare well on these, and practice more. That is what I suggest now and then. All right, so bye guys, thanks for your time, and we'll catch up tomorrow.